Welcome, everybody, to this joint webinar between Luceda Photonics and Spark Photonics about Process Design Kit, or PDK, generation and release. My name is Kevin McCumber. I'm the CEO and co-founder of Spark Photonics Design. We are a PIC design services and software company based in the United States, and we are the North American representative for Luceda Photonics, a PIC design software company based in Belgium. I'm joined today by my two colleagues, Cooper Hurley, a photonics design engineer here at Spark Photonics, and Aysan Anamoradi, an application engineer at Luceda Photonics. Let's take a quick look at the schedule. First, I'm going to hand it over to Aysan, who will give us an introduction to process design kits, or PDKs. And then we'll proceed to Cooper Hurley, who will talk a bit about the design house's perspective on PDKs, specifically Spark's perspective, as well as some insights into PDK development and how to simplify it. We are leaving ample time for a Q&A session so that we can take any questions from the audience and hopefully respond to anything that's top of mind for you. Just a little bit of housekeeping. During the Q&A portion, please feel free to even before the Q&A session, feel free to put your questions in the chat as they come up. Please reference the speaker and the slide number so we know what you're referring to, and then we'll collect those and we can answer them during the Q&A. We're also happy to take questions live during the Q&A if you'd like to unmute and ask them of us. And the number one question we get, yes, this meeting is being recorded, and that recording will be sent out to you after the event via email within a couple business days. So again, yes, this is being recorded and will be sent out to everybody who registered for the event. It'll also be posted on YouTube, so you can feel free to send it to others. All right, without further ado, it's my pleasure to introduce you all to Aysan Anamoradi, an application engineer at Luceda Photonics, who will be giving us an introduction to process design kits, or PDKs. Aysan, the floor is yours.
Hello. Let me share my screen. Right. Hello, everyone. My name is Aysan Anamoradi, and I'm an application engineer at Luceda Photonics. Today, I'm going to present a practical guide to PDK building and release using Luceda platform. So I will first give a short introduction to Luceda Photonics. Luceda Photonics was founded in 2014 from the Belgian photonics ecosystem. Our vision is to help photonic IC designers to enjoy the same first-time right experience as electronic IC designers. Our mission is to accelerate PIC design teams' time to market by helping them set up a flexible and efficient PIC design flow. We also have presence around the world, including a branch office in China. We have an official partnership with Spark Photonics in North America, and also we have resellers in Taiwan and Tokyo. Finally, we are a team of photonic experts who can help you achieve your goals. Here is an overview of the Luceda Photonics design platform. In the center, you see the core Luceda software, which we call it ADKs, with the features. To design photonic integrated circuits, you can start from component design to circuit design, and then do design validation. You can do circuit simulation, component simulation, and capture the schematic. And finally, you can also export your design to a GTS format. There are different design kits that we support on Luceda platform, and they are on different materials. We also offer assembly and testing design kits, which a designer should also think about during the design process. On top of Luceda ADKs, we have other products, AWG Designer, which is a tool to create AWGs. We have IP Manager and also Circuit Analyzer. We also have links for different device simulation tools like Lumerical, Simulia, and Tidy3D. We also have link for Siemens EDA, Checkmate DRC, and Opti Luceda COSI. So here is the photonic chip ecosystem. So the electronic photonic design automation tool is used by the photonic IC designers to design the chips. Then it will be sent to the foundry for fabrication. And after fabrication, it will be packaged and tested. So then at the end product is ready. A tool that designers need to design with the platform is PDK. And it is a process design kit that contains information regarding the rules and the fabrication process of the foundry. On top of that, there are assembly design kits and also testing design kits, which contain information regarding and rules regarding the packaging and testing houses. The focus of this webinar is on process design kits, and I will talk about this. So what's the value of a good PDK, and what's the value of enabling a PDK in Luceda platform? First of all, you can foundries can drive customer success. So their customers will move from can the chip be built to really build a right chip in the first time. And it reduces time to market for the design houses and also the foundry customers, and reduces time to volume production, both for the designers and also the foundry. Then a good PDK, a good process design kit is a powerful competitive differentiator, because with the data and the format of the information that the foundries put in their PDK, they can show their process maturity. And with those information, designers can reduce the risk of errors in their designs. And also quality of the PDK is as important as the quality of the process. So when you have a good process, you need to also represent it in a very good way. So you attract customers and designers. But the development of the PDK, which is a digital twin of your process, is not as expensive as developing a process. So it's very worth to invest on that. By providing a good PDK, you can do customer support. Foundries can do customer support in a more efficient way because their PDKs are user-friendly. The designers with the PDK can build more robust designs, and if not, the foundries can spot the designs that are sensitive to fabrication, for example. They can spot them easily. So all of this can again accelerate path to volume production. At the end, this can lead to stronger partnership between the designer and foundry because the communication is efficient through the good implementation of the PDK, and the foundry is transparent about the maturity of the process and their libraries. So let's see what process design kit contains. Basically, it has information regarding the technology, which is materials, layers, and process description, and as well as manufacturing rules. Then these are provided by the foundry fabrication houses, and then libraries can be developed by foundry as well as IP provider companies. So these libraries can contain photonic components, and they can contain from layout, model, and schematic. Then all of this should also be documented. So looking at the technology definition of the PDK, first we need to define the materials. They can be silicon, silicon nitride, and also you can implement the data, put the data in Luceda platform and use them. Then you can also implement the models for birefringent materials. Then you can define layers in Luceda platform as easy as these lines, like the layers. And then if you want, you can give them a purpose and also assign a GDS number to each layer. Then you can see and visualize them in Luceda visualizer and export them to the GDS. You can also describe your process in Luceda platform, which makes it possible to visualize the cross-section of the processes. And also, for example, your users, your customers can export 3D visualization of the component or circuit and see how it looks like in a three-dimensional board. Once the technology is defined, you can the foundries can put also rules regarding the manufacturing rules in their PDK, and if like it is also very readable, if this kind of rule can be defined in the PDK, and then with using checkmate DRC and also K layout DRC engine within from Luceda. The designers who use your PDK can visualize DRC errors. So if they can detect and visualize overlapping elements, acute angles, and also snapping errors. So it already reduces the back and forth communication regarding the DRC reports between foundry and the designer. But it's not only about visualization, but also about fixing. So we provide the users to address these DRC errors within Luceda platform. So the foundry can define a technology and rules, and then it's time to develop libraries. Libraries as are developed on top of a technology, and so they can again be defined by the foundry themselves, or can be defined by the an IP provider company. And these libraries can contain information regarding the layout, model, and schematic, which I will go through one by one. So the layout of the different components can be defined in Luceda platform in a parametric or fixed way. And then once they are defined, they can be simulated using our links with simulation tools. So the user doesn't need to interact directly with these tools. They can just generate the layout, and these will be automatically generated. And then they can also run sweeps directly from ADKs, like using these simulators. So they don't need to interact with these tools. And they can extract the data and save in their computer. So once the component layout is ready and it is simulated, foundries can or library providers can attach those models resulting from simulation to the components, and which is called a nominal simulation, which describes the behavior of the components and circuits in a perfect world condition, which is not the case. So the foundries can provide information regarding the variation of their processes, and so the designers can take into account the worst case extremes of manufacturing variations, which is called a corner analysis. They can also perform a Monte Carlo analysis on their circuits and get a real-world, predict the real-world production yield of their chip. And finally, they can also assess the variation and yield throughout the layout. So they can see with this information, they can see if how robust their design is against the variations of the fabrication. So this is about models. Then the library developers can also assign a schematic view to their P cells or parametric cells or components. And this will help the designers, like their customers, to design schematics using the components, and also then generate this layout from the schematic using Luceda platform. But also they can directly run simulations using this schematic view, which we call canvas. And run a time and frequency domain simulation, and also again they can directly perform the variability analysis in a canvas. So now the process is being developed, a library is being developed. The foundry and the library developers need to make sure that the quality of of their libraries is maintained, and then they can decide to distribute it. For the distribution, it is also very important to maintain that high quality. And also, when the PDK is developed within Luceda platform, it doesn't mean that all the customers should use a Luceda platform to design their circuits. So I will go through this again in a few slides. And then they need to define, put a documentation, generate a documentation of all the processes and technologies and components in their libraries and PDK. So let's see how this quality assurance is done during the PDK development or between the different releases of the PDK. So the component library, you work on it, you evolve it, and through the time, maintaining the quality of those components becomes more important, and it is very important to detect the changes. We provide a tool for regression testing that ensures the changes are tested and validated. Then, yeah, you can also do this PDK and this regression testing for each PDK release. Then it is about once the PDK is ready, you need to distribute it in different formats because your customers may use different tools. So from the Luceda technology, you can export to different formats and generate the PDK, like XPDK, open access, and text files, KLayout, LYP file. And then finally, you need to also generate the documentation of your PDK. So with Luceda, you can generate the documentation automatically. It will go through all the information in your PDK and files and generate a PDF file. And you can choose to generate a PDF file for the documentation or represent your documentation in an HTML format. And then once it's done, you need to, the distribution is, and it's now time to distribute the PDK. We can distribute a file that contains everything, and you can generate it automatically. It will, so when you distribute the PDK file to your customers, they can just drag and drop. If they use Luceda, they can drag and drop on Luceda Control Center, and they can, if you release different versions, they can switch between different versions directly from here. And also, they can access to the documentation using these buttons and go to the folder of your PDKs using this folder button. So then once again, I will go through the process of generating implementation of Luceda PDK for foundries. So the data can be, it can come into Luceda, and it can also be already a PDK. We can also generate a Luceda format of the PDK, and then again maintain it, then again export to different formats, do automated and peer-reviewed quality assurance within Luceda and also with the foundry. So it then the PDK is ready to be released. Thank you for your attention. Now, yeah, this was my presentation.
Great. Thank you, Aysan. And now it's my pleasure to hand over to Cooper Hurley, Photonics Design Engineer here at Spark Photonics, who will discuss Design House's perspective on PDKs.
Great. Thanks, Kevin. Go ahead and share my screen real quick. Can everybody see that?
Yes, and just a reminder to folks, if you have any questions, please feel free to drop them in the chat as we go, or save them for the Q&A. If you put it in the chat, we'll collect it and get to it during the Q&A. Thank you.
Great. Thanks, Kevin. All right. So real quick, I'm Cooper Hurley. I'm a photonics design engineer from Spark Photonics. We're a company that provides technical services, including design and layout, PDK development, and technical consulting. We're also a software provider. We're the North American partners of Luceda Photonics, and we handle distribution and support in the North American region. We also provide PIC kits, which are a fabricated chip on a variety of different platforms to be used as education and workforce development tools. So just to briefly discuss here, what makes a good PDK? So a good PDK will include a well-defined layer stack, which allows users to understand if the platform will be suitable for their application requirements. That layer stack coupled with optical material parameters allow users to accurately design components, ideally the first time. The PDK should also include some form of component library, which is a set of pre-developed components with documented performance specs, either simulated or maybe fully experimentally validated. And ideally, these components also include compact models, which allow PIC designers to simulate the circuit level performance of their design. Users coming from maybe a system level background might have little to no experience designing components on the individual integrated circuit platform, which means they could be heavily dependent on the quality and diversity of your component library and compact models. When any of this information additionally is not provided, there's an indirect cost passed on to users, whether it's excessive R&D costs, multiple fab runs to get their components right, or long timelines from chaining multiple fab runs end to end. It's best to not have your customers essentially reinvent the wheel every time they want to design something. And here on the images on this slide, you can see an example of a layer stack that's detailed fairly well, as well as some component data. You can see a waveguide effective index plot there, as well as temperature dependent component data on the bottom right, as well as a standard MMI component that might be available in a component library. So I'll next kind of walk you through the typical customer entry flow here and maybe give a little more insight as to how we leverage foundry PDKs in our standard day-to-day operations. So say a customer comes in with what they need. In this case, it would be a chip that operates at 850 nanometers with 1 gigahertz modulation. Next we would do a search of what foundries are out there that can accomplish this goal. To help bring into idea, what is, or to help reel in what would be within their budget. We also do a reference of what's out there in terms of already developed components. So this would be what's available in the component library. The less that they have to develop on their own, the lower the cost is. And then we would actually go and look to see, what's the cost to run this platform, what's the estimated timeline. And you can see that most of this information is actually in the PDK. So we like to think of the PDK as sort of at your front, as the front door of the foundry. And if something is not in your PDK, right, then you're not effectively selling it. It's really how we reference what is available at our foundry options that we're providing them. Next, I'd like to kind of look a little bit more into the ADK. So packaging is often seen as sort of an afterthought of the PIC design process. However, this can, quickly lead to budget issues. If we work backwards from the idea of, what will the final package need to look like in order to fit it in the ideal application for that chip, then we start to see what decisions need to be made in the layout phase to fully realize this. An ADK helps ensure the packageability by defining early on the required IO placements and electrical placements. And then this in turn will guide designers, how you place your components in the layout and structures to allow for these requirements to be filled. So on the bottom right, you can see an example of, your standard ADK inside of the PIC development software. And, designing these without these packaging requirements in mind usually requires pretty significant rework down the road, or at least a very expensive, complicated custom package that may not be commercially scalable, which is usually the end goal of a packaged PIC device. Now, to just sort of summarize the streamlined PDK development here, The goal is to maximize automation and scripting. When you use automation where you can script your P cells so that they can be easily reused. And then if you use automated DRC, users can check their designs themselves before submitting, ideally decreasing the amount of DRC flagging that the foundry has to do. Another goal would be to standardize and centralize your data. So that means keeping all the valuable process information in the same place. This includes, design rules and the device parameters. Additionally, it would be good to stick to your, typical naming conventions for layers, parameters, and files across your PDK elements and tools. Additionally, you would be good to employ a modular hierarchical design. This would be, try and develop P cells as independent units so that users don't need to know everything about the process in order to use them. And then also that includes implementing rigorous version control. So inevitably, when something changes, users know. Another goal would be to prioritize quality assurance. So Aysan mentioned this a bit. Develop a comprehensive set of, quality assurance cells and test cases for your P cells and DRC. This would help if you also could validate the simulation models against measured chip data that you get back from the fab. And then finally, streamline your documentation and support. Maintain updated design manuals and incorporate examples of different layouts inside your PDK. This can help users feel more comfortable designing into your platform with something they can compare as a good design. And then also design your get all your design knowledge and best practices into a really easy searchable database. This would also include maybe common issues that designers run into. That way you can reference this as sort of an FAQ troubleshooting guide. Next, I want to walk through a couple scenarios here. So let's say scenario one is a private fab wants to offer a foundry service, right? In the current state, they have scattered process knowledge. It's in a selection of different PowerPoints, Word documents, Excel spreadsheets in the heads of process engineers. And, they have a component library, but maybe some are only simulated. Some have been fabricated hundreds of times, but the data has never been formally extracted from those components. And, their current PDK might be enabled through a bunch of internal scripts based on Python or some other scripting language, and all the DRC is done by eye, right? It's just showing the layouts to engineers that have designed on it before and what's going to work, what's not going to work. In this format, the team's really not prepared to handle excessive support that opens once you try and take this foundry service and share it to a bunch of external customers. And that creates a large bottleneck, basically, in what kind of business they could eventually generate. From there, I'd say the target state would be, you've collected all this process knowledge into a concise set of PDK documents and technology files. You have a strong set of DRC rules that can handle error flagging. You've standardized the component library to include, components of varying maturity levels, whether they're simulated only or fully experimentally validated. And then you set up a method to distribute this PDK to others. And this can really seriously help free up the team's time to continue to innovate on the process side. And I would say that, the longer we wait to follow the good PDK practices, the more expensive it becomes. Spark and Luceda have significant experience helping foundries make this exact step towards commercialization. However, not just commercial foundries benefit from making these changes. Internal university foundries or internal foundries at your own company can benefit from these same changes to help improve the knowledge and knowledge transfer and process tracking as you make changes to your process. So ideally, everybody has a PDK, whether it's formally supported and created or not. It's whether or not it's well organized and easy to share is the real difference maker. Scenario two, this would detail a foundry that wants to update their existing PDK. PDK automation is incredibly important. It really seems like a waste of time until you jump into it. So let's walk through the process of a foundry that might want to make their release without doing proper quality assurance automation. So they release it, the foundry detects some errors in customer MPW layouts as they trickle in for the maybe quarterly MPW window. The foundry then has to scramble to update the PDK. That means, they're taking in whatever correction needs to be made, making the change, sending it out. But of course, this means that all the customers need to then fix their layouts and resubmit it, which means they have to widen the window of time that they can open that up for. The customers then, realize that maybe there's another error that's been introduced. Their layouts aren't compiling when they try to generate them, or even worse, maybe the foundry detects the layers or the errors again when the new designs come in. This typically leads to significant delays in MPWs, and unfortunately, it's not one of those things where this only happens once. This error window, we'd like to call, of making errors because the amount of time that you have to check your PDKs smaller generates higher risk, which is more likely to create mistakes in the work that you're doing. So ideally, instead, you have proper quality assurance automation. This checks, as you generate a PDK release to make sure there's no errors that'll break the PDK. Everything's in line correctly. This would allow the foundry to collect errorless MPW layouts, and therefore everything can kind of return on schedule. As I kind of mentioned before, it's the automation is really important. If you don't have it in place, it seems like everything is fine until it isn't. So it seems like a waste of time and effort when everything's working well, but without it, you are putting yourself at significant risk. And this is sort of a case for when you're looking at different EDA tools, right? Your quality assurance is going to scale ideally linearly, but it could be even worse. As you add more EDA tools, you have to support the PDK releases in different tools as well. Luceda is really capable of helping with this QA automation through their IP Manager tool. And so that's an effective solution for as you're trying to offer more EDA tools for your PDK platform. The support exists in that way. This next scenario here is, let's say that you're a foundry service, you have a novel component, and it's on one of your platforms. It has best-in-class performance, and that generates a lot of PDK inquiries, which can create more technical support, unfortunately, than your team might be able to handle. Each PDK requester probably has a list of questions. They want access to your PDK. This is going to create, unfortunately, a bottleneck in your business pipeline. So very few prospective customers can actually wait that long to obtain the PDK access. And most of them, will unfortunately go on to work with other foundries, maybe despite even lower performance, because they need to keep up with their project deadlines. So that's even though you might offer the best platform for what they need, there are other things at force here that will affect their judgment besides, what you're offering. And so, excuse me, anybody that does have the opportunity to wait that long will, be able to use your platform. But again, you're severely limiting the potential business you can convert when you don't have a properly set up business pipeline. And that's why, working with a PDK partner like Spark and Luceda, who we really know the technology well, we can improve your ability to respond to these technical customer inquiries, and then effectively widen this business pipeline to handle all of your potential customers and convert a higher percentage of inquiries into actual MPW riders. So in summary here, foundries are a service provider. You may be working to develop a specific process and sell that process, but the customers are in essence purchasing an experience from you. The better the experiences, the more likely these designers will return to your foundry for future projects. And easy ways to improve this experience is, offering an intuitive PDK, easy DRC, and packaging guidance. And then here's an example of an IP provider and foundry partner that we help support, OpenLight. And here's an example of a PDK enablement project that Spark led this past year with CHIPS Act. So I guess in summary, why work with us at Spark? We have an abundance of PDK development experience, as well as experience with the design and layout of PICs across many different technologies and foundries. Our partnership with Luceda offers us a unique opportunity to leverage seamless PIC design flow with our customers. Additionally, we're all US citizens, and we're currently performing on a US CHIPS Act Microelectric Commons project. So we have experience in that as well. And beyond that, I can accept any questions at this time. And if not, I guess I could pass it over to Kevin again.
Great. Thank you, Cooper. So we are now moving into the Q&A portion. I'll see if there's anybody who wants to ask a question live from the audience. Haven't seen anything in the chat. We'll just give it a minute here. Otherwise, I have some questions, real hard ones. All right. Seeing none, I think this might be a question for both of you. You both talked a little bit about, obviously PDK, but also ADK. I know this webinar is on PDKs primarily, but the ADK, the assembly design kit, is, I think, inextricably linked to the ability to take a chip to product. It's a design kit that's orthogonal to the PDK, lets it be packaged. There's also a concept of a TDK, testing design kit. Maybe this is first for Aysan. Could you talk a little bit about Luceda's kind of strategy around design kits, or how are you thinking about design kit implementation and kind of keeping the end in mind from the beginning of the design process, enabling designers to really have a full view of the end-to-end life cycle of a PIC as they start in design?
Yeah, thanks for your question. So as Cooper mentioned, that packaging is important, but also this testing is very important to consider at the very start of the design flow, because due to some reasons, the designers can, as Cooper said, put it in the last phase of design and don't think about it at the earliest stages, which will cause a lot of waste of money and time for the designers, because they need to redesign again to make, even if it's fabricated, they need to also align then with the requirements from testing or packaging. And so, like, for example, foundry said that I can create this spacing between couplers, but it's not possible to measure it due to the dimensions of optical fiber. So it is very good to put keep that in mind during the first stages. And also we offer different packaging and testing design kits, which really automates the design from the beginning. Like, for example, the placement of the grating couplers, the designer can just say, for example, I need 10 couplers. They will be placed and generated on the frame automatically. If they violate the rules of packaging and testing, like too small or too big chips, they can see it in the early stage. Also, they can also follow the testing or packaging conventions, for example, regarding the placement of optical I/O at the east and west of the chip, and also electrical I/O at the north and south of the chip, and many other things. So all are defined in, and they can be used together parallel with the PDK. So yeah.
Right. That was something I didn't understand when I was kind of first heard of an ADK, is that it's not foundry dependent. You have an ADK that's packaging firm specific, and then you have a PDK that's foundry specific, and the two kind of overlay. The ADK uses the PDK components to define the electrical and optical I/O, and that was very much an eye opener for me, and probably for a lot of folks who haven't heard of an ADK as well. Cooper, any thoughts to add about what you're seeing customers use as far as the other design kits, the ADKs and TDKs?
Yeah, I think this is more of a experience with design, or not design, but packaging houses. I think a lot of packaging houses are at the point where they're very excited for business, and so they will make a lot of accommodations for any specific design that comes through their door. But what they don't realize is, by making essentially an ADK, right, a list of restrictions, it makes things a lot clearer, so that down the road, right, maybe a foundry would be willing to do something in the short term for a small scale project, or if a design or a packaging house would be willing to make accommodations for a tight fiber pitch or an unconventional design decision. But the ADK that a packaging house provides allows for scalability in the future, which is something that I think most designers want to keep in mind when they're making their first prototypes. So even though it may seem like a really good business prop to accept anything that comes through your door, you're actually ultimately limiting your potential for their business maybe down the road by not providing that ADK.
Absolutely. In my opinion, the integrated photonics ecosystem will benefit from some standardization and streamlining of these parts of the value chain. So I think having design kits very much helps that. I'll just pause and see if there are any questions from the audience. Otherwise, I have another one to Cooper this time. All right, Cooper, in your experience with non-foundry customers, let's say, I think there's a lot of them on this webinar, so kind of want to give them a shout out. What are you seeing as typical struggles as they're going to scope a project or thinking about where to go to find a foundry? What tends to stand in their way or serve as a roadblock that we as a community could try to address?
Yeah, I think the typical customer benefits most from looking at the MPW runs of different foundries. Multi-project wafers are a great way to get your foot in the door in design and get your R&D designs out there so that you can proof of concept any basic chip that you would eventually like to maybe do it in your entire own custom run down the road. Lining these up can be challenging because a lot of times they run on 3 or maybe more month intervals. And so timelining becomes a very serious factor. Not every customer can add 3 to 6 months to their timeline to hop on a very conveniently timed MPW run. So in that, being very conscientious of how you're scheduling your runs and keeping them on very regular timelines can be really important for converting business. Additionally, right, having quick responsiveness from the foundry for any questions and being very easy to work with oftentimes converts to really happy customers, which means returning business. So I would say those 2 factors in mind are really important. Just those are beyond obviously the factors of the process and the platform that they're working on, but they can seriously impact whether or not a customer moves forward with you as a foundry.
I'll pause here and see if there are any more questions from the audience. All right. Aysan, maybe I can put you on the spot with this question from the Luceda perspective. If you kind of had your wish list of things that could be improved in the ecosystem from an EPDA vendor's perspective, what would you say might be the top, 1 or 2? By the way, for everybody's edification, if you haven't figured out already, these are not rehearsed. So these are real-time responses. You can put them in the hot seat. Give you a little second to think there.
So something is that I think it's important to do is a standardization, and also something maybe simple, but it's good to do is to name the process PDK and change the components. Like when we say PDK, it's not obvious if it's only process and also library of components. So I think it would be good to all the users, like photonic designers, photonic IP providers, use these terms to clarify what they mean in their communication.
Thank you. Oh, great. We have a audience question. I will ask, how far are we from the goal of having a DRC clean silicon photonics tape out? Maybe I'll pass that to Cooper.
Sure. Yeah. I think that's a good question. I assume you mean on the foundry side of getting a full reticle without any DRC flags. Yeah, I think the goal here is to integrate DRC more into the customer's side. So as you are designing your layout and your tape out, you have the DRC rules from the foundry for that specific process. And you can essentially run it as a final check. We work with the Luceda platform. So when we generate our script that makes our GDS, we include a script line that runs our own internal DRC on our designs using Checkmate. And so this essentially makes it so that our DRC is completely, green, good to go when we move to submit it. That I think decreases the amount of work on the foundry side to do this, although this is not a standardized process yet. We would like to kind of push for it to become more of a standardized process. I think that works towards the goal of decreasing potential roadblocks and hiccups in the reticle configuration process, and helps decrease the amount of work on the foundry side to do that. Whether how far we are away from that, I can't say for certain, but I think it's something that we on the design house side are trying to standardize internally at least, and maybe that'll move forward as a industry-wide standardization.
Yeah, thank you. I forgot that I could just unmute myself, but and is it a realistic goal? Do you think we can reach would the SIFO reach the DRC clean target?
I think it's a combination of there are, DRC flags can be challenging. I think a lot of times they're a product of just the GDS2 format too, but I think that the push towards, accurate waiver layering to prevent, unintended DRC errors from cropping up where they are, and then also, if there is a legitimate DRC error, then users can correct it themselves. I don't think it's unreasonable. I think we've noticed that depending on the format that we're working on, our platform or our chips in, we catch different errors. GDS2 is a little out of date, so maybe down the road when they make GDS3, it'll be a little more able to handle some of those point-based errors and grid-based errors. But I think it's a great question. If we were to design a full reticle for you, maybe we could work on it internally. But once it becomes adopted by the greater community, I think that's where we'll see it become more of a likelihood.
Yeah, no, I agree. Thanks. Yeah.
Sure. Thanks for the question. Any other questions? Please feel free to unmute. All right, hearing none, we'll go ahead and wrap up. Yes. I have one final backend slide here. All right. So should you have any interest in reaching out to us, please feel free to use one of these QR codes. You can also reach us at lucedaphotonics.com and sparkphotonics.com. Very much appreciate everybody joining today. Again, this has been recorded and will be sent out to all the registrants afterwards, as well as posted on Luceda Photonics YouTube channel and publicized over social media. Thank you all. Hope you have a great day, and I hope you learned something today in this webinar.
Thank you.